Hey everybody, it's Keith with Bob CNC. Welcome to Shop Talk. And what are you doing?
Wave it.
Oh.
Hi guys.
As always, I'm next to my, I don't know.
He doesn't wave.
No, I
Wave for
don't.
you too.
Oh, thank you.
Keith says hi.
Anyway, that's Bob. I'm Keith, and
Yeah.
we're talking about.
And we're best friends.
Yes, we are.
We've been talking about how to build your own CNC.
Yes. And today we're going to talk about structure.
Ooh, structure.
Structure. One of the things I've heard you say, in fact, I just heard you talking about it before we started, is that the best or the optimum CNC that you could build theoretically would weigh nothing.
Yep, and be really rigid.
And be really rigid.
Yeah.
And now I know people who think like that and are really rigid, but I don't know, how would you build something without any mass and it would be rigid?
Yeah, the bottom line is you can't, but engineering.
Then why'd you bring it up?
Engineering is always a compromise. I mean, let's just walk through, so you have, I guess you could say, a plastic CNC, right? So they'd have to be really, really big, right, to get any kind of rigidity, but it'd be fairly light, so that'd be okay, but it wouldn't be very rigid. So you could do a plywood, which is, what our designs are, and you could make it rigid enough, and it would be light enough. And then you could do it out of aluminum, and the geometry could be a little bit smaller, and it would be light enough, right? And it would be rigid enough if you did the design right. And the same thing for steel, but you could go all the way up to titanium. Now one may be less expensive. Titanium would be great, right? Because it could be super rigid and still lightweight. But there's calculations out there, and actually they're fairly simple calculations that you can look up online, and you can find the Young's modulus of the material, and then you can for simple shapes you can find the inertia. So you can figure out your deflection for this shape. However, very few people would do that, or would he want to do that, or know how to do that. But there is software out there, Fusion 360, Design Spark Mechanical, and I'm sure there's others, so don't get upset with me because I didn't mention them, that actually you can just 3D model up a shape and it will kind of give you that information. So the bottom line, if it's kind of intuitive, right? If you have something that's really big and mostly tall, right, it'll be a lot more rigid than if it's just really skinny. And also you would say, yeah, steel is a lot stronger than paper, right? So some of that's intuitive. So the bottom line is if you were going to build a CNC router, let's just start off with a gantry because you're going to have to move that back and forth, right? You could build it out of a solid block of, like a railroad tie, and it would be plenty rigid, but man, would that puppy be heavy, right? So now you got to get these great big motors to push it, and then once you get it going, you have to stop it, so the inertia of it would be ridiculous. I mean, everything would not turn out well. It would be rigid enough, but it would be so heavy that it would not do for a good CNC machine. Okay, well, fine, then we'll go the opposite extreme and take a cardboard tube and stick, and it would be super light, so your motors would be able to have good acceleration, deceleration, and it would be great, but it wouldn't be very rigid for the other components. So somewhere in between there's a compromise of how rigid you can be and yet light enough. Now you'll notice if you go look at an industrial mill or even a knee mill, right, or something that like a Bridgeport that I used to have. It's 3,000 pounds. The cutting area is 12 by 18, but it's got mass, right? And that does more for you than just rigidity. It keeps down the harmonics and everything. But the bottom line is it?
It sounds like a boys band. What do you mean harmonics?
Well, I mean things vibrate, right? And if things vibrate, then you get chatter. We don't notice that so much with wood, although it's there. But with the metal stuff, you need to dampen all of that, plus you need the rigidity to do those things. So really it's a compromise. So you're going to design your own CNC, so you got to pick your material. We choose wood because it's easy to design, right? You can make the gantry as tall as you want, and we do a tab and slot design to bolt it together. Aluminum's really a popular choice in the fact that you have the 80-20 extrusions, or the extrusions that have a place where you can tap the ends and bolt pieces to them, and then it has a place where you can connect your linear rails or design those, but they're pre-made for you. They're a little bit more expensive to do it that way, and for the gantry you may end up having to stack or put some plates to make it stiff enough, or get bigger aluminum extrusions. Then if you have a welder, you can do the steel, right? And if you have a plasma cutter, so you can cut out some of the holes that are needed and weld it up, then you can do it that way also. So it's not that one is right and one is wrong. It's what tools do you have, and what are your capabilities of being able to manufacture that. So the bottom line is if you're going to be serious about it, you really probably ought to look into some software so you can get some numbers and know how much it's going to weigh, because most of your simple software, if you model it in 3D and tell you that it's wood or aluminum or steel, it's going to give you the weight, and then it also will give you the mass moment of inertia so that you can calculate how rigid it is, or just know that number needs to be big. And if you have that number, that it's really a hand calculation to figure out how much deflection that you're going to have for a simply supported beam. And if that all sounds crazy to you, just look it up online. Simply supported beam, there's some calculations, you'll figure out the right one. And if not, ask me, I should give you the right one. We did a video on it a long time ago. Yeah. Yep. So that, this is the bottom line. There's one of my engineering buddies used to say, and I don't know if it was his or not, when in doubt, make it stout. And then he would say something about grind it, paint it green, or something like that. But anyway, grind to fit. Anyway, I won't go there.
Okay.
Maybe you already did.
No, I was kind of enjoying it.
You like that, huh?
Yeah.
Okay. But the bottom line is you want it to make it as stout as you can, if you're, like kind of guessing. But just remember, the weight of that system is going to hurt you as well, right? It's because you're going to have to get bigger motors, or you're just not going to have the performance. So that's why I say what you really want is something really super rigid with as very light as possible. That would be awesome.
I noticed, this is a little bit of our history, that when we had the E series, 3 and 4, even when we went to the Evolution, we used to get a lot of hits online about people making fun of wood designs. But, with a history now of 6 years, and I'm saying this to encourage you, there's absolutely nothing wrong with using wood. We don't hear those comments anymore.
No, there's definitely a design element, right, to try to optimize it. But there's several wood machines out there that have been out there, for quite a while doing good work. So ours is just one of them.
Yeah. Well, anyway, guys, if you have any questions about design, structure, materials, that kind of stuff, you can get a hold of us at the help desk at bobcnc.com.
Yep.
And we'd love to hear from you. So till next time.
Yeah.
We'll see ya.
Send us a picture of those.
I said we'll see ya.
Fine. Send us a picture of your machine anyway.